Article 210.19. A.3 of the National Electrical Code states that branch circuits rated 20 amps or less shall not supply appliances rated over 18 amps. A 30 amp rated UPS exceeds the 18 amp limit when connected to a 20 amp branch circuit. Article 210.21. B.1 requires overcurrent protection devices to be installed in accordance with the ampacity of the conductor. A 20 amp branch circuit will not provide adequate overcurrent protection for a 30 amp UPS. UL ratings are based on specific product combinations, including the overcurrent protection and conductors used. Connecting a 30 amp UPS on a 20 amp circuit would void the UL rating, as it would not meet the specified safety criteria. Connecting a 30 amp UPS to a 20 amp circuit is not acceptable because it raises several safety concerns, including the potential for overheating. A 20 amp branch circuit could overheat due to the excessive current draw from the 30 amp UPS, potentially leading to an electrical fire. The UPS may not be able to provide the necessary power to the medical device due to the undersized circuit, potentially damaging the device or impairing its functionality. Additionally, using an incompatible power source could void the warranties on both the UPS and the medical device. To rectify this situation, firstly, install a dedicated 30 amp branch circuit for the UPS. Secondly, use a smaller UPS with a 20 amp rating. Thirdly, find a different vendor that can provide a compliant solution. It's crucial to understand the implications of connecting a 30 amp uninterruptible power supply to a 20 amp branch circuit, especially when powering sensitive equipment like medical devices. The National Electrical Code, or NEC, provides specific guidelines to ensure electrical safety and prevent hazards. Article 210.19. A.3 of the NEC addresses the limitations and the load that can be connected to a branch circuit. Specifically, it states that branch circuits rated 20 amps or less should not supply appliances or equipment rated over 18 amps. This provision is designed to prevent overloading the circuit, which can lead to overheating, insulation damage, and potentially electrical fires. When an appliance or device is rated at 30 amps, it implies that it could potentially draw up to 30 amps under certain operating conditions. Connecting such a device to a 20 amp circuit creates a significant risk of exceeding the circuit's capacity. The NEC also addresses overcurrent protection in Article 210.21. B.1. This section mandates that overcurrent protection devices, such as circuit breakers or fuses, must be installed in accordance with the ampacity of the conductors in the branch circuit. In other words, the overcurrent protection device must be sized appropriately to protect the wiring from excessive current. A 20 amp branch circuit should be protected by a 20 amp circuit breaker or fuse. If a 30 amp UPS is connected to this circuit, it could draw more than 20 amps under certain conditions. While the 20 amp circuit breaker would eventually trip, it may not trip quickly enough to prevent damage to the wiring or the UPS itself. This is because the wiring and components are not designed to handle sustained currents exceeding their rated capacity. Furthermore, electrical products often carry a UL, or Underwriters Laboratories, rating. This rating indicates that the product has been tested and certified to meet certain safety standards. UL ratings are based on specific product configurations and operating conditions, including the overcurrent protection and conductors used. Using a 30 amp UPS on a 20 amp circuit would violate the conditions under which the UPS was UL listed. This means that the UPS may no longer meet the specified safety criteria, and its UL rating would be void. In addition to the NEC violations and UL rating concerns, there are several other safety issues associated with connecting a 30 amp UPS to a 20 amp branch circuit. One of the primary concerns is overheating. When a circuit is overloaded, the conductors and connections can overheat. This overheating can damage the insulation on the wires, leading to short circuits or ground faults. In severe cases, overheating can ignite nearby combustible materials, resulting in an electrical fire. Another concern is potential damage to the equipment. The UPS may not be able to provide the necessary power to the medical device due to the undersized circuit. This can cause the UPS to operate erratically or shut down unexpectedly. It can also damage the medical device, impairing its functionality or rendering it inoperable. Finally, using an incompatible power source can void the warranties on both the UPS and the medical device. Manufacturers typically specify the correct voltage, amperage, and other electrical requirements for their product. Using a power source that does not meet these requirements can invalidate the warranty, leaving the user responsible for any repair or replacement costs. Given these concerns, it is essential to avoid connecting a 30 amp UPS to a 20 amp branch circuit. The proposed solution of using a pigtail connector to adapt the 30 amp plug to a 20 amp receptacle is not a viable or safe option. This approach does not address the underlying issues of overloading the circuit and violating the NEC and UL requirements. Instead, there are several alternative solutions that can be considered. Firstly, installing a dedicated 30 amp branch circuit for the UPS. This would involve running a new circuit from the electrical panel to the location where the UPS will be installed. The new circuit should be wired with appropriately sized conductors and protected by a 30 amp circuit breaker. This option would ensure that the UPS has adequate power and is protected against overcurrent conditions. Secondly, use a smaller UPS with a 20 amp rating. If the medical device only requires 12 amps, a 20 amp UPS may be sufficient. This option would eliminate the need for a new circuit and would comply with the NEC requirement. However, it is essential to ensure that the 20 amp UPS has enough capacity to handle the medical device's peak power requirements. Thirdly, finding a different vendor that can provide a compliant solution. Some vendors may offer UPS systems that are specifically designed for use on 20 amp circuits. These systems would be UL listed and would comply with the NEC requirements. It is important to carefully evaluate the vendor's offerings and ensure that they meet the specific needs of the medical device. In summary, connecting a 30 amp UPS to a 20 amp branch circuit is not acceptable due to the NEC violations, UL rating concerns, and safety hazards. The proposed solution of using a pigtail connector is not a viable option. Instead, consider installing a dedicated 30 amp branch circuit, using a smaller UPS with a 20 amp rating, or finding a different vendor that can provide a compliant solution. By following these guidelines, you can ensure the safety and reliability of the electrical system and protect valuable equipment from damage. When dealing with electrical installations, it is crucial to adhere to the guidelines and regulations set forth by the National Electrical Code, or NEC. The NEC is a comprehensive set of standards that govern the safe installation and maintenance of electrical systems. It is designed to protect people and property from electrical hazards. One of the key principles of the NEC is to ensure that electrical circuits are not overloaded. Overloading a circuit can lead to overheating, insulation damage, and potentially electrical fires. To prevent overloading, the NEC provides specific rules about the maximum load that can be connected to a branch circuit. A branch circuit is the portion of an electrical system that extends from the last overcurrent protection device, such as a circuit breaker or fuse, to the outlets or equipment that it supplies. Article 210 of the NEC covers the requirements for branch circuits. Section 210.19 specifically addresses the ampacity of conductors in branch circuits. Ampacity refers to the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation, and other factors. According to Section 210.19, A. Branch circuit conductors must have an ampacity that is not less than the maximum load to be served. This means that the conductors must be sized appropriately to handle the anticipated current draw of the equipment that will be connected to the circuit. In addition to the conductor ampacity requirements, Section 210.21 of the NEC also addresses the rating of overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. When the current in a circuit exceeds the rating of the overcurrent protection device, the device will trip or blow, interrupting the flow of electricity. This prevents the circuit from overheating and potentially causing a fire. According to Section 210.21, B. Overcurrent protection devices must be rated in accordance with the ampacity of the conductors that they protect. This means that the overcurrent protection device must be sized appropriately to protect the wiring from damage. In the case of a 20 amp branch circuit, the overcurrent protection device should be rated at 20 amps. This will ensure that the circuit is protected from excessive current. When connecting equipment to a branch circuit, it is important to consider the equipment's rated current draw. The rated current draw is the amount of current that the equipment is expected to draw under normal operating conditions. This information is typically found on the equipment's nameplate or in its instruction manual. According to section 210.23 of the NEC, the total load connected to a branch circuit must not exceed the rating of the circuit. This means that the sum of the rated current draws of all the equipment connected to the circuit must not be greater than the circuit's ampacity. In the case of a 20 amp branch circuit, the total load connected to the circuit must not exceed 20 amps. When connecting an uninterruptible power supply, or UPS, to a branch circuit, it is important to consider the UPS input current rating. The input current rating is the amount of current that the UPS will draw from the branch circuit when it is charging its batteries or supplying power to connected equipment. If the UPS input current rating is greater than the branch circuit's ampacity, the circuit will be overloaded. This can lead to overheating, insulation damage, and potentially electrical fires. In the scenario described, the UPS has an input current rating of 30 amps, while the branch circuit has an ampacity of only 20 amps. This means that the UPS is not compatible with the branch circuit. Connecting the UPS to the branch circuit would violate the NEC requirements and could create a safety hazard. As mentioned earlier, the proposed solution of using a pigtail connector to adapt the UPS plug to the branch circuit's receptacle is not a viable or safe option. This approach does not address the underlying issue of overloading the circuit. Instead, it simply allows the UPS to be connected to a circuit that it is not designed for. This could create a dangerous situation. Instead of using a pigtail connector, the correct solution is to either install a dedicated 30 amp branch circuit for the UPS or to use a smaller UPS with an input current rating that is compatible with the existing 20 amp branch circuit. Installing a dedicated 30 amp branch circuit would involve running a new circuit from the electrical panel to the location where the UPS will be installed. The new circuit should be wired with appropriately sized conductors and protected by a 30 amp circuit breaker. This would ensure that the UPS has adequate power and is protected against overcurrent conditions. Using a smaller UPS with an input current rating that is compatible with the existing 20 amp branch circuits would be a less expensive and less disruptive solution. However, it is important to ensure that the smaller UPS has enough capacity to meet the needs of the connected equipment. In conclusion, it is essential to adhere to the NEC requirements when connecting equipment to electrical circuits. Overloading a circuit can create a safety hazard and could potentially lead to an electrical fire. When connecting a UPS to a branch circuit, it is important to consider the UPS input current rating and to ensure that it is compatible with the circuit's ampacity. If the UPS is not compatible with the existing circuit, the correct solution is to either install a dedicated circuit or to use a smaller UPS.